Okay, so in this video we'll be solving problem number 2.7 from the Introduction to Mechanics by Kleppner and Kolenkow. So what this problem says is that I have this setup and I have this rod leaning here of length L, and there are two masses M and N, both are of M mass, are attached to the upper end and the lower end of the rod, right? So what I want is, first of all, I want to find a constraint relating the vertical acceleration of one end and the horizontal acceleration of the other end. So what essentially would be the equation would be x squared plus y squared equal to L squared. That is, by Pythagoras theorem, we can say that at any moment, though whatever be the value of x and y, this relation will always hold. So I take the derivative on the both sides, so it will be 2x dot plus 3y dot equals to 0. That's all. It will be 2x x dot plus 2y y dot equal to 0. I will again take the derivative of this thing, so I will take 2 common, and it will be x double dot plus x dot, right, and plus y double dot plus y dot. Okay, for those who are not familiar with this representation, so a single dot means a single time derivative, and double dot means a second time derivative. So it's a little bit easier to write it down rather than always using d square y upon dt square and again and again. So yeah, okay, so this will be x double dot plus x dot whole square plus y dot whole square plus y double dot equal to 0. Now if x dot equal to 0 and y dot also equal to 0, I mean, it means that rod is at rest. So how the acceleration will be x double dot equals to minus of y double dot, and x double dot will be equal to minus of y on x y double dot. That will be minus of tan theta, if this angle is theta, so definitely this would be some x value and this is some y value. So tan theta would be y upon x, and that's what I'm placing it here, and y double dot. So the equation is x double dot equals to minus of tan theta y double dot, right? Okay, now I'll move to the next problem, the second part of the problem. For that, I need to clear off the page here. Okay, so now we will solve the second part of the problem, and what the second part of the problem says that now suppose that each end of the rod has a particle mass m, this thing, and I need to find initial vertical and horizontal components of acceleration as the pole begins to slide on the frictionless wall and the floor. So assume at the beginning of the motion, the force exerted by the rod along the line only. Okay. So what happens is that this rod will apply some force Fp in this line, and again there Fp in this line, and let's say this thing makes some angle theta, so obviously this thing will also make some angle theta here, and what will happen is that since m is pointed to this rod, the acceleration of the mass m here in the y direction will be the same as the acceleration of rod in y direction, and so same goes for the x direction too here. So what will happen is that we take up Fp sine theta, and minus of mg will be equal to my squared. Okay, that is the equation 1. I mean, let's not name the equation because I don't need that to. Yeah, and fx squared will be Fp cos theta. So this thing goes here, so it will be Fp cos theta. So this thing will contribute to the acceleration in the x-axis, and here is your Fp in the y direction, Fp sine theta, and here is your mg. So obviously the difference between them will contribute in the acceleration in the y-axis, right? So what I will do is, this implies that Fx upon cos theta is equals to Fp, and I will put this thing here. So it will be mx double dot sine theta upon cos theta minus of mg equals to my double dot. So m, this cancels out, and I'm left with tan theta x double dot tan theta minus of g equals to y double dot. Right, and now here we have learned this relation. So I will just put it there. So in place of x double dot, it will be minus of tan squared theta y double dot minus of g equals to y double dot. This implies that y double dot equals to minus of g upon 1 plus tan square theta, right? And what I will do is, let me open it up a bit. Y double dot equals to minus of g sine squared theta plus cos squared theta minus cos squared theta, right? Okay. It's a bit messy, but anyway, so this will go to 1. So this implies that y double dot is minus of g cos squared theta, right? Now I will take up this thing now, because obviously I'm supposed to find x double dot and y double dot. So I have my y double dot. Now I will take up this equation and put it here, and we'll evaluate for x double dot. So it will be x double dot tan theta minus of g equals to minus of g cos squared theta, and x double dot tan theta equals to g 1 minus cos squared theta, x double dot tan theta equals to g sine squared theta, and x double dot equal to sine theta upon cos theta equals to g sine squared theta, and sine and sine square cancels out, and this implies that x double dot equals to g sine theta and cos theta. Here's my answer. See you in the next video.